Thank you. So first up, we have Vangelis Katsinas talking about haptics in audio mixing interfaces. Over to you.
Thank you very much for the introduction. Hello, everyone. My name is Vangelis. I'm a music producer. I'm a sound engineer and currently a PhD student at the University of West London. My research focuses on haptics in audio mixing, which is also the topic of my presentation today. And to start this talk, I would like to pose a question. Have you ever thought about how the tools we use in audio mixing shape the way we mix sound? How the audio mixing interface itself, to an extent, dictates the way we approach and practice mixing? Let's see the next slide. Before the advent of computers in the field of music production, before those, sound engineers relied primarily on their auditory modality and skills than visual feedback. But as computers evolved and as screens became larger and more detailed, more and more audio parameters transitioned into visual representations, making visual feedback central to the mixing process. Today, I will introduce you to the fascinating world of haptics and explore how audio mixing can benefit from this technology by leveraging our powerful sense of touch, potentially improving usability and cognitive performance. I will start by explaining what the term haptics means. Haptics refers to the human sense of touch. The haptic sensory system, the haptic channel, allows us to feel things as we touch them. Haptic modality communicates and processes information coming from the haptic channel to the brain. And in modern times, haptics encompasses the entire ecosystem of touch-related technologies, whether software or hardware, that enable users to interact haptically with virtual objects in digital environments, also known as computer haptics. So how can we combine haptics with audio mixing? Although there isn't a magical way to instantly improve our mixing skills, there is one factor that often limits our ability to perform to our highest potential: our brain. And the way our brain works is that it allocates a certain number of cognitive resources across all sensory modalities: the visual, hearing, taste, smell, and touch. Of course, we don't use all of them when mixing. So what happens to the rest of them? Well, the first interesting thing is that cognitive resources not utilized by one modality cannot be redistributed to another, meaning they essentially go to waste. The second interesting thing is that when overusing any single sensory modality leads to cognitive overload and underperformance. Let me give you a common example of underperformance in the field of sound mixing that you might have experienced. Imagine mixing a project for several hours until late in the evening. You're happy with the mix. You go to bed, you wake up next morning feeling excited about listening to your mix. You open the project, you press play, and it sounds horrible. So what happened is that at some point, your brain got tired by processing all the audio and visual information, and you started making the wrong decisions. So how can haptics help with that? Haptics can minimize cognitive load by either sharing some information with the auditory modality or by replacing certain visual information, reducing this way dependency on the screen. Now, most of the information we see on the screen is audio parameters: the volume, the panning, reverberation time, frequency, the ratio. So in order to integrate haptics into audio mixing, we need to find creative ways to haptically represent these audio parameters. In the following slides, I will present to you some of the prototypes I have designed by haptically augmenting virtual fader, mapping various haptic parameters to volume. What I'm examining is whether haptics can minimize cognitive load, that's the mental effort required to complete a task, the mixing task in this case, or improve usability. And usability includes efficiency, effectiveness, and user experience desirability. The prototypes are based on a multimodal system, and the haptic device I'm using is the Inverse 3 by Happily Robotics, which is a 3 degrees of freedom force feedback device that enables the user to feel certain attributes of virtual objects, such as the weight, the size, the texture, the shape, the elasticity. Now, the first prototype is a haptically augmented virtual fader that integrates a haptic effect called detents. For those of you who haven't heard the term detents before, it's a useful haptic effect that is used in many controllers to mark up specific positions in the controller or indicate regular intervals. Think of the pan-pot control. When you move it right in the center, there is a subtle haptic click, so you know it's exactly at the center without looking at it. In this case, I'm using detents to indicate an increment of 1 dB. It could be anything, but 1 dB seems to make sense. So let's say I want to increase the volume of vocals by 2 dB. Now, normally I would be looking at the screen while doing this, but with the haptic interface, I can increase the volume while focusing at the sound, and the haptic interface is going to notify me about the volume change, reducing this way dependence on the screen. The second prototype, unlike conventional controllers that use fixed friction like the fader and knobs, this prototype is based on the brain's ability to detect changes in friction. So in my study, I'm investigating whether variable friction can convey audio parameter information. Resistance is mapped to volume, so as the value of the encoder increases, the fader becomes stiffer, and vice versa. I have also designed hybrid prototype that combines both haptic effects. Detents seem to provide a more precise representation of a volume change, whereas variable resistance is more abstract feedback. And finally, this last prototype is based on the idea of why improve an outdated controller like the fader, which, by the way, was invented or designed in the 60s, when we can create one specifically designed for haptics. So in this example, I have created a 3D haptic sphere that takes full advantage of the haptic interface's capabilities by moving in all 3 axes. And I'm using this haptic sphere to manipulate or to control a fully parametric equalizer. By moving the sphere across the horizontal axis, I manipulate frequency. I'm using detents to indicate specific frequency bands like low, low, mid, mid-high, and high. Moving the sphere across the vertical axis, I can manipulate gain, and I'm using detents in increments of 1 dB. And moving the sphere inside out manipulates the bandwidth of the filter. And for this parameter, I'm using variable resistance. So as the filter becomes narrower, resistance increases. I hope this introduction to haptics has given you a glimpse into the possible implementations of what haptics can do with sound mixing. Thank you for your kind attention, and let's move into the Q&A. Thank you.
Thank you for that. It's a great talk.
Yeah, thanks very
Really
much.
interested. I know we were talking before a bit, weren't we? So with these prototypes you've got, are you looking, you were saying, at Unreal Engine to realise some of these ideas? Is that correct? Or
Yeah, that's true. So the haptic integration and the graphic design of all the prototypes is through Unreal Engine.
Mm-hmm.
The audio is coming through F mode. I just found it a bit easier to manipulate sound, especially not so much for these prototypes, but I'm also haptically augmenting the stage metaphor, so there's a lot going on, and I found Unreal Engine a bit restricting with regards to manipulating and controlling audio parameters.
What? Okay, yeah, that's fine. I mean, what version of Unreal Engine are you using? Is it 5? Or?
I started with 4.27,
Yeah.
and then moved to 5.1. These last prototypes are designed in 5.4.
Brilliant. Okay, so with, all I was going to say is with 5.4, with that new meta sound system, you've now got an output subsystem that's been put onto that meta sound system. So it might be worth looking at that as
Definitely.
well. So you can basically output back into the engine harmonic frequency content of a sound.
Awesome.
And yeah, just like different amplitudes, and you can throw all that back out as well. So
It's
just,
great to hear that Unreal Engine finally upgraded their audio engine, right?
Yeah, 100%.
Yes, and thanks very
so
much for that,
we'll have
yeah.
a chat afterwards, obviously, but it might be something that might work quite well for you. Okay, thank you.
Thanks, that was really interesting. So with sound engineers and music producers and stuff, you often get quite a lot of sort of tacit knowledge with being very used to the tools that they already have, being very used to sort of, the 1 degree of freedom on the fader and things like that. So how do you think you will deal with sort of trying to retrain some of these professionals to your tools that, can often have quite a different paradigm of working to one that they're used to before?
Very good question. Well, the first step is not to retrain them, but in order to collect useful data. Whenever you evaluate a novel interface compared to a standardized interface like the channel strip in this case, there is the bias of familiarity. And to add to that, resistance to change. So let's say you have designed a novel interface that in reality is much simpler than the mixing desk. But hey, I've been using the mixing desk for 25 years, and although it's complex, now that I know how to use it, I don't want to switch to another interface. So my answer to that is that precisely because you have to acknowledge that there is no way to retrain professionals. This is a study. I'm trying to collect some data in order to, I don't know, possibly at some point we can switch to another audio mixing interface. But before that, in terms of collecting data, my answer is that you conduct formal experiments to collect mixed data, both quantitative and qualitative, and then you run an autoethnographic study that you have the chance to use the interface, not just for half an hour or an hour, which is pretty much the time that your participants will use the interface, but maybe for a few months, and then you overcome the limitations of familiarity and resistance to change.
Great, thanks.
Thanks very much.
Thank you. I'm afraid that's all the time we have for this round of applause for Vangelis.